Welcome back to another lesson of BDD with Cucumber and Serenity. Last time, we learnt how to use scenario outlines to run the same scenario with different values that we can define in a tabular format. In this lesson, we'll be learning how to use tables of data in a different way to define test data at different stages in a single scenario. And we'll see how this can be really useful when we have to define more complicated data structures in our tests. Imagine that Sarah wants a cappuccino and a muffin. Our application needs to make sure she's charged the correct amount based on the prices of each thing she orders. So our test scenarios will need to know how much each item costs. If we were in the coffee shop and checking the bill by hand, we would just look up at the price board. How can we do the same thing in a Cucumber scenario? In Cucumber, we could express these costs one by one using a string of given statements like the ones here. But this text is quite hard to read, and there's a lot of repetition that we don't really need, even for this simple example. But Cucumber gives us a much better option. We can use a table just like this one to represent the data instead. This table represents the same 5 rows of test data that we had in the previous example. But we don't need all that repeated text in each line. And the meaning of the table is pretty clear. It's even quite close to how the business would express it themselves. We can use tables inside steps in another way too. Suppose we need to check the contents of the receipt that our application generates. The printed receipt looks a little bit like this one, where the line items for each purchased product appear, and then we have a subtotal and a total that includes the 5% Caffeinate Me service charge that we add. How would we represent this in Cucumber? Well, we could write something like this. Given Kathy has ordered a large cappuccino and a muffin, when she asks for a receipt, then she should be given a receipt totaling subtotal $3.50, service fee $18, and total of $3.68. Notice how we've got a table after the last line? This is a bit like the previous scenario, where we passed in a table containing our test data to the given step. But here, instead of passing in rows of test data, we're representing a single object with 3 fields: subtotal, service fee, and total. Later on, you'll see how we can use this data inside our step definitions. These are the 2 basic uses of data tables in scenario steps, either to pass in a collection of test data or to pass in a single object with several field values. We can use any approach at any stage of a scenario. For example, if we are checking the receipt that we can see up here, we really should check the line items as well. For example, we could add another line, and the receipt line items should be, and then list out the line items in a table. There is one other step in this scenario where we might be able to use embedded tables. Can you guess which one? That's right, the first one. Given Kathy has ordered a large cappuccino and a muffin, we might be able to write this step in a way so that it works with 1, 2, or several items in the order. Let's see how we could do this in Cucumber. If we wanted a bit more flexibility, we could put the items in a list, like this. Given Kathy has ordered the following: large cappuccino, muffin, and tea. This reads less smoothly than our previous example, but it does let you put as many items as you want in the list. But a list format like this can make the line a little bit hard to read because it can become quite long and go off the edge of the page. Another option is to use a single column table like this one. Here we don't have a column header, we just have a list of values that will get passed in to the step definition methods. Another more flexible approach is to use an embedded table in our scenario like this one. The table looks like the tables that we've seen in our previous examples, where we have column headings and rows. Here we have two columns, one for product and one for quantity. In each row, we have a product, large cappuccino, muffin or tea, and the quantity. So one large cappuccino, two muffins, and one tea. This approach is very flexible. We can put as many products as we want and as many quantities as we want as well. Now let's see how we can work with these tables in our own step definitions. Let's start off with something simple. Cucumber makes it really easy to pass in a comma-separated list of values to our step definitions. I've created a new file called askforareceipt.feature, and I want to create some scenarios. The first scenario will be order several items. I want Sarah to order several items, so a large cappuccino, a muffin, and an espresso, for example. To do this, I'll pass in a list of values separated by commas that I want to pass through to my step definition method. Let's create the step definition method now. In the step definition method, I can get rid of the hard-coded values and I'm going to replace it with a wildcard expression. And I want to pass in a parameter. The parameter will be a list of strings. And Cucumber will transform the comma-separated list of values into this list of strings. Just to prove that, I'm going to print the value of the list of strings so that we can see what actually happens. Now let's run the test and see if it does actually print out the values we expect. If we look at the ask for a receipt result, we can see that we do get large cappuccino, muffin, and espresso. We could also express the same data as a list like this, just a single column table with each row representing one line of data. If we do this though, we need to change the step definition a little bit. We can see here it's no longer defined. This is because we don't need the wildcard expression when we have an embedded table. Let's run this test and make sure it still works. And there we have it. We've passed in exactly the same values, but using an embedded table instead of a comma-separated list. But what if the data is more complicated? For example, if we want to pass in both a product name and a quantity. We could write a table like this, where we have the quantity in one column and the product in the second column. And this way we could write 1 large cappuccino, 2 muffins, 1 espresso, and so forth. How do we pass this into our Cucumber step definition? Well, one way we could do it is to pass in a list of maps, like this one. We have a list of maps of strings to strings. The column heading is the key, and the values in each row are the values. So we have a very literal representation of the table as a list of maps. Let's run this to see if it still works. If we look at the outputs, we can see that Cucumber has passed in a list of maps. So how could we use this list of maps in our step definitions? Remember, we have a method on our customer class called places an order for. So one way we could implement this step definition would be to write something like this. We take our orders object and we do a for each. So for each item for each element in the orders list, we're going to extract the product name and the quantity. So remember, order is a map of strings to strings, so we can just say order.getProduct, but for the quantity we're going to need to convert it to an integer, so we'll need to do integer parse int of order get quantity. Then we can just call places an order for quantity product. As usual, let's run the test and make sure it still works. And it does. But dealing with maps is a cumbersome way of working. We have to extract and convert each column value individually. And Java is really not the most convenient language in the world for working with maps. Wouldn't it be nice if Cucumber could do this sort of thing for us? Well, it turns out it can. If we create a class that represents a row in the table, we can do just that. Let's create a class called OrderItem. We'll give it two fields, product and quantity. We can make it a very simple class. It's essentially just a value object that contains a field for each column. Now let's get IntelliJ to add getters and a toString method for us. Now back in our step definition method, we no longer pass in a list of maps, but we pass in a list of order item objects. And we can dispense entirely with this conversion logic. We just need to retrieve the value because Cucumber will have converted each row of the table into an order item object. Let's run this to prove our point. And here you can see the order item objects that have been passed into the list by Cucumber. So far, you've seen a few ways that we can use tables inside steps in Cucumber scenarios, and some of the ways that these structures map to our step definition methods. Time for a break. We'll be back in the next lesson to continue this same example further and to see what it feels like to put some of these concepts into practice.